Good morning and welcome back. So, resonance occurs when the driving frequency means the external frequency means the frequency of the external periodic force. That frequency, the frequency of the external periodic force, when it is equal to natural frequency of the body, there is resonance. There is resonance means the body vibrates with maximum amplitude. So if there is resonance, the amplitude is maximum. What happens if the frequency is different? Suppose if you plot the graph of frequency against amplitude, y एक्सिस पर है amplitude of vibration, x एक्सिस पर है frequency, then the graph is like this. This is the graph of amplitude against frequency. You'll notice here that as the frequency is increasing here, the amplitude is increasing. ये देखिए इतनी frequency पर ये amplitude है, frequency बढ़ गई, amplitude increased, frequency और बढ़ी, amplitude और बढ़ गया. At one particular frequency, the amplitude is maximum. और frequency अगर उससे आगे और बढ़ती है, suppose यहाँ पर आ गई frequency, amplitude और कम हो गया, frequency और बढ़ी, amplitude और कम हुआ, and so on. This means that the amplitude is maximum at a particular frequency. Which is this frequency? This is the frequency of the external periodic force, which is equal to natural frequency of the body. ये है body की natural frequency. और ये frequencies क्या है सब? बाकी external frequencies. So when the frequency of the external periodic force is equal to natural frequency, the amplitude is maximum. अगर driving frequency नेचुरल फ्रीक्वेंसी से थोड़ी अलग है तो एम्पलीट्यूड कम हो गया, और ज्यादा डिफरेंस है एम्पलीट्यूड और कम हो गया ऑन बोथ द साइड. सो एट वन पर्टिकुलर फ्रीक्वेंसी द एम्पलीट्यूड इज मैक्सिमम. दैट फ्रीक्वेंसी इज कॉल्ड रेजोनेंट फ्रीक्वेंसी. रेजोनेंट फ्रीक्वेंसी एंड दिस कर्व इज कॉल्ड रेजोनेंस कर्व. कौन सा कर्व है ये? Resonance curve, the curve of frequency against amplitude. In the previous lecture, while talking about resonance, I gave the reference of sonometer experiment. The sonometer experiment, which is performed to find out the unknown frequency. अगर आपको एक ट्यूनिंग फोर्क दिया हुआ है और बोला है कि इसकी फ्रीक्वेंसी फाइंड करो, you can find the frequency of that tuning fork by using sonometer experiment. What is that experiment? In that experiment, there is a hollow wooden box. There is a hollow wooden box. Okay. This is the box which is used in sonometer experiment. Sonometer, Sonu Nigam nahi, sonometer. So this is the box used in sonometer experiment, a hollow wooden box. Now, on this wooden box, from one side, a string is tied. That string passes over a pulley, and on the free end of the string, there is a weight pan or weight hanger. You know both. Weight pan, एक pan है where you add the weights, or there is a weight hanger in which you go on attaching the weight. So either there is a weight pan or a weight hanger. For what purpose? To provide tension to the string, because without tension wave will not be formed. So to provide tension to the string, the weights are added in this pan or this weight hanger. तो क्या क्या है यहाँ पर? A hollow wooden box. From one side, a string is tied which passes over a pulley, and the free end of the string is attached to a weight hanger or weight fan. And below this string, there are two movable supports. Two movable supports. You can move them from one place to other. So these two movable supports, which are called knife edges, two movable supports. We are going to study the vibration of the string between these two supports. इन दो supports के बीच में जितनी string है, हम उसके vibration की study करेंगे. Therefore, this much length, the length between two supports is called the vibrating length of the string. So this is the apparatus used in sonometer experiment. अब अगर आप इसमें weight add करते हो, there will be tension in the string, and if you pluck the string at any point, a wave will be formed which will be reflected from the support, and transverse waves, means loops, will be formed here, and the frequency of that string will be P upon 2L under root E by M, as we saw in the previous lecture. P is the number of loops, length of the string, tension in the string, and linear density. So that will be the frequency of the string. अगर आप weight change करते हो, if the tension is changed, the frequency will change. If you keep the tension constant, weight change नहीं करते हो, keep the tension constant and move this bridge, means vibrating length will change, and if vibrating length changes, frequency, the natural frequency of the string will change. This is natural frequency of the string. So if the length changes, the natural frequency of the string will change. Now you are given a tuning fork and you have to find out the frequency of that fork. What you do, you hammer that fork, the fork starts vibrating. You touch the stem of that fork to this sonometer box. Touch the stem of the vibrating fork to the sonometer box. The vibrations of the fork will be transferred to the string through the hollow box. Hollow box में से होते हुए वो vibration string तक पहुंचेंगे. So the string will also start vibrating. Now the frequency of the string will be different, obviously, from frequency of that fork. Now you change the length of the string. ये support को आगे पीछे करके देखो. As you change the length, the frequency of the string will change. And at one particular length, एक length ऐसी होगी, you go on adjusting the length. At one particular length, the natural frequency of the string will be equal to the frequency of the fork. अब fork यहाँ पर driving frequency है, external frequency, और ये है body which is vibrating, which is having forced vibration. The string is having forced vibration. So at one particular length of the string, the natural frequency of the string will be equal to the frequency of the fork. Resonance will occur and the string will vibrate with maximum amplitude. To know when the resonance takes place, you keep a paper rider on this string. पेपर राइडर मतलब कागज का एक टुकड़ा लेके उसको ऐसे फोल्ड करेंगे और स्ट्रिंग पे रख देंगे. पेपर राइडर is kept on the string. When resonance occurs, the string vibrates with maximum amplitude. Due to that, this paper rider will be thrown off. So when the paper rider is thrown off, you come to know that the string is vibrating with maximum amplitude. The string is vibrating with maximum amplitude means the natural frequency of the string is equal to frequency of the fork. Resonance has occurred. So frequency of the fork, capital N, will denote frequency of the fork by capital M, will be equal to frequency of the string, because paper rider is thrown off, resonance हुआ है, frequency of the fork is equal to frequency of the string, और frequency of the string क्या है? So you know how much is the tension, you know what is the length, vibrating length, आप measure कर सकते हो यहाँ से. Mass per unit length of the string is already measured, पहले से measure करके रखा हुआ है. So you get frequency of the string, and that will be the frequency of the fork. So that's how you can find out the unknown frequency, the frequency of the fork, using sonometer experiment.